Welcome to The Explainer. Today, we're going to break down something pretty wild, how Netflix's engineering team took one of their most important systems and just absolutely supercharged it.
And when I say supercharged, I'm not kidding. We are talking about a jaw-dropping 100 times performance improvement. Now, this wasn't some minor tweak. This was a fundamental overhaul that completely changed the game.
So what was the problem? Well, the team figured out they weren't just fighting slow code. They were up against something much sneakier, a hidden performance tax. A tiny, almost invisible delay on every single task that when you multiply it by millions was absolutely crippling their efficiency.
And just how crippling was this tax? Get this, they did the math, and the number they came up with was just staggering. All that combined overhead added up to the equivalent of 57 days of wasted computing time. And that wasn't over a year. That was every single day. A massive amount of resources just vanishing into thin air.
Okay, so let's start with the before picture. The system we're talking about is called Maestro. You can think of it as Netflix's digital orchestra conductor, responsible for coordinating millions and millions of background jobs that have to run every day. And for years, Maestro worked just fine. It was built for those big, heavy lifting jobs, things like generating a daily report or crunching some numbers that might run once an hour or so. In that world, a few seconds of startup delay, who cares? It's basically a rounding error. But here's the thing, Netflix's business evolved. All of a sudden, they have these real-time services like ads, games, and live events. And suddenly, that little rounding error wasn't so little anymore. It became a huge bottleneck. I mean, a 5-second delay is an eternity when an ad needs to be served right now. So the old system was built on a model called polling. The best way to picture this is to imagine a group of workers just constantly bugging their manager. Hey, is there anything for me to do yet? How about now? Is there something now? It's a simple way to do things, yeah, but all that constant checking just naturally introduces delays. And this slide right here, this just perfectly illustrates the core issue. The old workers were stateless, which is a fancy way of saying they had amnesia. For every single tiny step in a process, a worker had to go to the database, read the entire instruction manual from page 1, do its one tiny job, and then, poof, forget everything. It was unbelievably repetitive and, you guessed it, slow. So instead of just trying to make these forgetful workers a little bit faster, the team realized they needed a totally different approach. They had to give the system a memory. It was time for a complete brain transplant for Maestro. This was the game-changing idea. They decided to completely move away from that pool of amnesia workers, and instead they gave each individual workflow its own dedicated, smart actor, a tiny, lightweight process that remembers everything about its own plan from start to finish. And what's really cool about this is how the actor model works. Each workflow gets its own little brain that lives in the computer's super fast memory. It doesn't need to keep asking what's next because it already knows. As soon as one step is done, bam, it instantly triggers the next one. This completely gets rid of polling and all those slow, painful trips to the database. Okay, so that's the big idea. It sounds great in theory, but how did they actually pull this off and make it so ridiculously fast in practice?
Well, it wasn't just one single magic bullet. It was actually 4 key changes that, when you put them all together, created this massive speed up. Let's break them down.
First off, they kept the live active state of a workflow in that super fast computer memory. The database was still there, but only as a backup for emergencies, not for the second-to-second operations. This alone cut out a huge source of slowness. Second, they made sure that all the different steps within a single workflow were grouped together on the same physical server. This idea is called co-location, and it means they could get rid of slow middlemen, like an external message queue. Communication between steps became almost instant. It's like passing a note to the person next to you instead of sending an email and waiting for a reply. And finally, they used a cutting-edge programming feature to make this whole thing possible at Netflix's scale. Java 21's virtual threads are like incredibly lightweight, efficient little workers. This new tech allowed them to create millions of these individual actor brains without totally overwhelming the servers, something that would have been pretty much impossible just a few years ago. So after this absolutely monumental effort to rewrite Maestro's core, what was the actual payoff? Was it all worth it? Oh yeah, the results were nothing short of dramatic. The startup overhead for every single task just plummeted. It went from around 5,000 milliseconds, that's 5 whole seconds, down to just 50 milliseconds.
That is the 100-fold improvement they were looking for. Just incredible. And as the Netflix team themselves put it, this whole thing proves that performance really, really matters. Even in these massive web-scale systems, the latency of those tiny individual operations makes a huge difference to everything: developer productivity, user experience, and the bottom line.
You know, this project offers some seriously powerful lessons for anybody building software. The biggest one for me is that a smarter architecture will be trying to optimize a broken one every single time. They also proved that keeping related work physically close is a performance superpower, and that moving to a cleaner, event-driven design can just wipe out entire categories of problems. And that really leaves us with one final thought. Things that seem simple and scalable on the surface, like polling and stateless designs, they often come with these hidden costs. They impose a tiny tax on every single operation that can add up to a massive burden over time. So the real question is, where is that hidden tax in your own systems?